Okay, so we're picking up here on page 2. And this is going to build on what we did on Friday. Okay, so this is our general power rule, and I think it kind of, if you ask me, sums up the 3 rules we did on Friday. So the derivative of the term a x to the n, where a and n are real numbers, is a times n, then x to the n minus 1. Okay, I'm going to basically want you to think about, in order to take the derivative, like what we were doing on Friday, the power of n moves out front and multiplies out front. So thus, it's going to be n times a, or a times n. And then what do you do to the power? And then to the power, you're going to subtract 1, yes? So it's still those same 2 pieces here. You're going to move that n out front, and then we're going to subtract 1 from the power. That's all it is. So if we're doing the derivative of y equals 3x squared, I'm going to write it as y prime, and I'll take steps on some of these. So start with what we did on Friday. The power moves out front, so now it's going to be 2 times 3x, and then what do I do with the power? Subtract 1. So 3 times 2 times 3 to the x of 2 minus 1. Say what now? Be parentheses. You do not have to have parentheses on any of this. All we have to do is clean it up. 2 times 3 is 6x. And there you go.
Nice.
Okay. That's the basic, right? That's level 0, level 1, whatever you want to call it. Okay. Are we okay with that? Okay, next one. Negative 5t cubed. So I'm going to write this as s prime of t. What am I doing first?
Negative 5 times 3.
Yeah. Negative 5 times 3, and then t to the 3 minus 1. And I'll be honest, folks, don't feel like you have to write this step out with me. This is our learning step. It feels I struggle writing it out because it's very awkward for me. Okay, but it's our learning step at this point. Negative 5 times 3 is negative 15, t to the 2nd. By all means, jump to that final answer when you hit that point. Maybe you don't want to do that in your notes because you want to have it to look back at, but in homework, jump to that final answer if you can.
Can we turn the lights up? I'm going to fall asleep.
I like it.
We can. What do you know about c? Y equals 6 square root of x.
1/2.
Yeah, before you do this derivative, is that okay?
Thanks.
Before we do that derivative, realize that this is 6 times x to the 1/2. So anytime you see any type of root, radical, change it to a fractional exponent. So y prime, what am I doing?
1/2 times 6
1/2 times 6.
times x 1/2 x or minus 1.
Okay, x to the 1/2 minus 1. Okay, half times 6. Half of 6 is 3. 1/2 minus 1,
Negative
negative 1/2.
3 over
3 over square root.
So that negative takes the exponent to the denominator. The 3 is going to stay on top. So it's 3 over x to the 1/2, or in other words, 3 over the square root of x. And to me, both these final answers are right. The only thing I would say, it gave me square root of x to begin with, so ending with the square root in your answer is usually a good thing. However, I'm not opposed to the other answer. Okay, D, what do you need to do before we get started?
pull it out. But, no.
Yeah. This is our general power rule. It has to be in the form of a times x to some power. So this is rewritten as what?
3x and then
Are we good with that? 3x to the negative second? And then do your derivative. G prime of x is going to be Negative 2 times 3x to the negative 2 minus 1. What does that clean up to be?
Negative 6 over x2.
I wrote mine as negative 6, x to the negative third. Again, we probably shouldn't leave it like this. Go one more step. And this is negative 6 over x to the third. Are we doing okay?
Yeah. Got stuck on E.
Okay. I say I don't even think most of you are on the same problem I'm on, honestly. I don't know, but okay. So what's my starting step on E?
You get it out of the fraction. Well, you can.
You have to get it out of the fraction. This is 4x to what power getting us started?
Negative
1/2.
Because you're pulling it out of the denominator and out of the radical. You have to pull it out of both of those. Okay, so f prime of x. Negative 1/2 times 4 x to the negative 1/2 minus 1.
Yeah.
Okay. Negative 1/2 times 4 is negative 2. X to the negative 1/2 minus 1.
Negative 3.
Negative 3 halves.
3 halves.
Negative 3 halves.
And then do you leave it in the fraction, like exponent?
You can.
Okay.
So go one more step, definitely, because right now I have a negative exponent, yes?
Yep.
So when we get it out of the negative exponent, I'm going to have negative 2 over x to the 3 halves.
Negative 2 over the square root of x.
I actually left mine like this, surprisingly. However, and here's the deal. It's just all about knowing that they're equivalent, okay? I'm fine with this. This is what my answer key has. Now, if you go for radical, this is the square root of x to the third. Technically, you could go another step farther than if you're going to go radical, because there's a perfect square in there. Yes? No? Technically, you could say that this is negative 2 over
X.
x square root of x, right? Because the square root of x squared is x, and then you still have an x under there. Now, all three of those are equivalent. Understanding equivalency is what's important here. With that in mind, in my answer key, I have the very first one listed. I don't even have the other two listed. Okay. Are we good? Okay, let's try one more. What do we know before we get started?
Negative 8.
Negative
4 over 3.
Yeah.
Negative 4/3?
Yeah.
I was really having to think hard about that one because I heard you, and I was like,
I looked up
Yeah. and I just about wrote it. I was like, wait, think. My brain wasn't thinking either. Okay, negative 8x to the negative 4/3. We're good there, yes?
Yes.
Okay. What do we have?
Negative 4/3 times negative 8.
Negative 4/3 times negative 8. X to the
Negative 4/3 minus
negative 4/3 minus 1. Okay, fun. Negative 4/3 times negative 8.
32 over 3.
32 thirds, nothing reduces there. X to the,
Negative 7
over 3.
okay, negative 7/3,
Yeah.
because 1 is 3/3, yes? When we subtract 1, we're subtracting 3/3 here. Negative 4/3 minus 3/3 is minus negative 7/3. Now, options. Get rid of the negative exponent. Now, to get rid of the negative exponent, properly written, x to negative 7/3 goes to the
No.
denominator. What's already in the denominator? 3. So, 32 over 3x to the 7/3 would be how my answer key stopped. Okay?
Jesus.
I mean, if you wanted to, 32 over 3 times the cube root of x to the 7th. Technically, there's a couple perfect cubes in there. Technically, you could say 32 over 3, so x squared, right? Because x to the 7th isn't a perfect cube, but x to the 6th is, or x to the 3rd, and there's 2 of them. But x to the 6 divided by 3 is going to make that x squared times the cube root of x. And this is why we just stayed right here.
Yeah.
I mean, and again, is there importance in understanding the equivalencies? Yes. Because you never know what form they're going to put something in multiple choice. You never know. So you need to be able to, I mean, this is just algebra that I'm doing right here, right? This is the stuff you're supposed to already know. My job is to review it with you. Or at least I take that on as my job. Technically, no, you're just supposed to know it, but that's a whole other story, right? Okay. Ready for the next section?
Yeah.
Because now we're going to start adding and subtracting in our derivatives. It's no different. We're doing the same exact thing we have been. Okay. So the derivative of a sum or difference is the sum or difference of the derivatives. Now, that's fancy speak. It is good to understand. Okay. The derivative of a sum is the sum of the derivatives. So this is saying, this right here is saying the derivative of the sum. So it's saying the derivative of when you add f and g is equivalent to the sum of the derivatives. Meaning I just take each individual derivative and add them. Okay, so if you have multiple terms, and same is true about subtraction, if you have multiple terms being added or subtracted, we don't do anything fancy. Derivative of the first term minus derivative of the second term, plus derivative of the third term minus derivative of the fourth term. That's all we're doing. Okay, when you have pieces being added or subtracted, just take each derivative. Piece of cake. That's all that rule is saying. Multiplying, dividing, not piece of cake. That's probably another day. I doubt we're doing I don't think we're doing product and quotient today. No. Okay, that's a whole nother world. Sum and difference, piece of cake. Just do each individual derivative. So, let's do it. Example A. F of x is x cubed minus 5x squared plus 2x minus 7. F prime of x. Do you want me to write out all the pieces, or can we just do this together? What's the derivative of x cubed?
3x squared, 3x squared.
Are we there? Can we handle that on the basics?
Yes.
I can't remember that.
I just gonna need a
You multiply, move the 3 out front, subtract 1 from the power, thus 3x squared. Minus derivative of 5x squared.
10x minus 2.
10x to the first, but I'm just going to write 10x because we moved the 2 out front, and then 2 minus 1 is 1. Plus derivative of 2x. 2. Yep. Officially, this falls into our special cases. This falls into derivative. What's the second thing we did? How was it phrased?
Single variable.
Single variable rule. Now, here's the deal. Can we still use our power rule?
Yes.
Multiply the 1 out front. 1 times 2 is 2. Subtract 1 from the power. 1 minus 1 is 0. X is 0 is just 1. You get rid of that variable. Okay? Minus derivative of 7.
7.
Nope.
0.
0. Okay? That is the very first thing we did, which was constant rule.
Oh yeah, and then
Okay? The derivative of a constant is always 0. Just keep in mind, we're just going 1 less power, yes?
Mm-hmm.
Okay, well, there's already no power, so we just have, it's gone. Okay? Or think about the line y equals negative 7. What's the slope of the line y equals negative 7? 0. So, when I would be writing this answer, I would write 3x squared minus 10x plus 2. No, you're not going to see me write that crazy 0. That was a one-time deal. Okay? B.
You're telling me I got that? Nice.
Are we good?
Yep.
5 times 2/5. The 5's cancel, and that is 2x to the 4th when you subtract 1 power. Okay? Plus derivative of x to the 4th.
4x.
Move the 4 out front, subtract 1 from the power. 4x cubed.
6x.
Derivative of 3x squared.
Plus
2 times 3 is 6. Subtract 1 from the power. 6x. Minus derivative of 1 is 0. I told you that was a one-time deal. I'm not writing 0 again.
Why not?
This stuff is easy.
You know, I hope this is easy on
It's never like that, Kylie.
It's never.
I honestly don't remember.
I'm not gonna get my hopes up.
Well, and the thing is, we're not done with the lesson yet,
Yeah.
right? But I mean, I'm pretty. What else could homework be? It's doing a whole bunch of derivatives, isn't it? Mostly. I don't know. There's always some tricky ones. Okay, so moving along. Now, are you guys good to go, or what should we probably do before we start this problem?
Take it out of the square root.
I would encourage you to rewrite this. So notice this is just g of x. I'm not doing g prime of x yet. G of x is x to the
1/3 plus 5x.
okay, x to the 1/3 plus 5x to the 1/2. Are we good there?
Yes.
Okay, now I'm ready to find g prime of x. Derivative of x to the 1/3.
X to the negative 2.
Are we good there? 1/3 minus 1. So 1/3 minus 3/3, that's negative 2/3. Plus,
So we just do 5/2 eggs.
okay, I would. A half times 5, I would encourage you to write 5/2 x to the
Negative
1/2 minus 1 is negative 1/2. Now we've got some negative exponents happening. So I've gone one more step on my answer key. My answer key does have it with exponents, but not negative exponents. So, what are we thinking?
5.
Let's start on part 1, please.
1 over 3x.
1 over 3x.
1 over 3x to the 2/3 plus
5 over 2x to the 1/2.
Okay.
Sorry.
And I'm not saying you couldn't do this in the other order, but I'm trying to be consistent and keep in the order we already have it written.
I was just going to put in the biggest one first. So.
Not bad.
No. And then
Well,
I
but
changed it.
when we put it in positive exponents, 2/3 is a bigger exponent than 1/2.
Yeah, but the 5 over the 2x, so half's going to be bigger than the
But you put it in order of exponents when you go highest to lowest.
Oh, really?
I changed it to the square root of
Okay.
or cube root. Is that right? So would
Yeah.
it be 1 over 3 to cube root of x?
Cube root of x squared, yes.
Okay, and then 5 over 2x.
2 square root of x.
Yes, that's.
I know you meant, but that's not what you said.
It's not the same.
Okay,
I'm stressing.
y prime. There's one part we should probably rewrite before we get started. And that is, what do you know about 4 over x?
4
What is that? X,
x minus.
I'm not gonna rewrite the whole thing. I'm just crossing out the x and it's x to the negative 1. Okay. Y prime. Derivative of 5x to the 3/2.
15 over 2x.
To the 1.
1/2. I think.
Yes. Yes.
15/2 x to the 1/2.
Come on, that was good. Pretty much.
Please tell me. I feel like looking around and listening to you guys, we're all on the same page here.
Yes.
I don't feel like I'm leaving anyone behind. But if you've got questions, please slow me, stop me.
I agree, Oreo.
I'm not there yet.
I got 30 over 3.
But what is
Oreo.
okay? So 6 times 5/3. Are we there?
Yes.
It's 30 over 3,
Just 10.
which is 10. X to the what?
1/3.
2/3.
2/3.
1/3.
Because 5/3 minus 1, so 5/3 minus 3/3. Then what?
-4.
X to the negative 2.
Minus 1 times 4 is going to make it minus 4. Subtract 1 makes it x to the negative 2. Again, all I did was get rid of negative exponents here. So I still have 15 halves x to the 1/2 minus 10 x to the 2/3 minus
4 over X squared.
4 over x squared. Okay, 2 more at the top of the next page.
6x.
Yeah.
Volumes.
Okay. Okay. H prime of x. Derivative of 3x squared is 6x. 2 times 3 is 6. Subtract 1 from the power.
Plus 8 X to the negative 3.
Okay? Now, do I need to, if I rewrite this up above, this would have been what? Minus 4x to the negative second. Do you need to see that?
Yeah.
Please write that visual out for yourself if you need to see that, because that's one that you have to stop and really think. And I don't know that, I struggle with that sometimes, so I don't know that we can all, just jump right into it, but maybe we can. I don't know. Okay, so negative 2 times negative 4 does make it plus 8x to the, subtract 1 from the power, and negative 3. Plus, and again, what do we know about 2 square roots of x?
That's 2X.
2x and 1/2. And so this becomes
This X to the negative 1.
1x to the negative 1/2, because half of 2 is 1. Subtract 1 from your power. So h prime of x is 6x plus 8 over x cubed plus 1 over x to the 1/2, or plus 1 over square root of x. Which, funny enough, I actually wrote it as 1 over square root of x in my notes. I'm not very consistent. But then again, that probably means she's not very consistent either on this stuff.
Oh,
I couldn't tell you the next one.
what? Do I have to multiply it by all of those pieces? Or just toss it on the end?
You can just it's 8x squared plus 4x minus 3 over x.
Yes.
What?
What?
Why, Doug?
Because you're dividing by x. They all have x. It's with them. It's just taking the coefficients and then the last one is negative.
If these are all dividing by x, there's one x, right? It goes into all of these. So you can think of this as 8x cubed divided by x plus
That's what I was asking.
4x squared divided by x minus 3 over x. Okay, sorry, I didn't comprehend.
It's okay.
I might have been dealing, I just scraped the top of my foot on the bottom of this,
Oh, no.
and I was dealing with I was distracted by pain for a moment. Sorry, bad excuse, I know, but
It's okay.
it did make me pause my thinking. Okay, so 8x cubed divided by x means I'm going to be taking the square root of 8x squared. 4x squared divided by x means we're going to be taking the square root of 4x minus 3 divided by x means I'm going to be taking the square root of 3x to the negative 1. That's me writing out what I'm taking the derivative of. Maybe you find that unnecessary. I call it helpful. I also struggle as a calc teacher who's been doing this for years to figure out how quickly your brains pick all this up. So, okay. What do we know? Derivative of 8x squared
16x.
plus derivative of 4x
4
minus derivative of 3x to the negative 1.
plus 3
Plus 3 over x.
I'm going to write it as 3x to the negative 2 for right now. Because negative 1 times negative 3 is positive 3. Subtract 1, x to the negative second. However, final piece, 16x plus 4 plus 3 over x squared. Okay? You're going to see a lot of just doing this type stuff in homework. I can't say we'll all do this, but you have to just get these rules stuck in your head, yes? Okay? You have to get these rules stuck in your head. I lost track of how many times that was. Okay. Now we're going to look at some special cases. We're going to look at derivatives of cosine and sine, and then eventually e to the x and natural log of x. Okay? All we've done so far is general power rule. It is just if you have x to some power, that is the rule we use. So that covers a lot of things, but it doesn't cover everything. And so past knowing your power rule, you're just going to have to flat out memorize rules. Okay, it's just flat out memorization to being able to know what to do here. And so the derivative of, I guess they just state it right here, but then we're going to consider the graphs and how it connects here. So, which means I probably gotta go ahead and go to the next page. Yep. The derivative of the sine function is the cosine function. Consider where the sine function increases, the cosine function is positive and vice versa. So, right off the bat, being told the derivative of the sine function, so derivative of sine x is cosine x. Now, with that in mind, okay, what graph do I have showing here?
That's sine.
This is sine, yes? This is good old graph of sine x. And I'm putting that on there so we definitely know. But some things to consider. Well, actually, how do I want to do this? Okay. Sorry, fits better down there. Y equals sine x. Think about what's going on this curve as to what the derivative will be doing at this point. Okay, so what does sine start off doing? It starts off going what? Going up, so it is increasing, yes? What would that say about the derivative at that point? The derivative should be positive. And it's going up to a... about a max. Okay. What's going to be the derivative at this point?
0.
Derivative is going to be 0. Okay, then what's happening? Okay, then my graph is decreasing. Right here, we do have a 0. It's also technically an inflection point. Okay. My graph is still decreasing. Decreasing down to what? Okay. The point is 3 pi over 2 comma negative 1, but it's a minimum, and so the slope is 0. And then what are we doing here?
Increasing again.
We're increasing, yes? Okay. Now, what is this the graph of?
Cosine.
This is cosine x, right? And what were we just told?
I don't want to.
We were just told the derivative of sine x is cosine x. Now, pair it together. Right here. And we're just going to worry about from 0 to 2 pi. From 0 to pi over 2. my graph was increasing. What does that mean about the derivative?
It's positive.
It's positive. What do we notice here? This is right here, it's above the x-axis, and above the x-axis because it is positive, right? Above the x-axis in a derivative graph means it's positive.
I thought cosine was valley. Or not valley, no. Well.
Sophie.
No, it starts here. Okay, then at pi over 2, we had a max. A max has a slope of
0.
0. What do we have here?
An inflection.
We have a 0. And it's because there was a max. Well, what it's representing here is it's a 0, right? And it's representing a max. Now, pi over 2 to 3 pi over 2. What do you notice from pi over 2 to 3 pi over 2?
Decreases.
My entire graph is decreasing. What do you notice about the derivative graph?
It's negative.
Okay, it's negative, and it's below the x-axis, right? And below the x-axis is indicated as negative. Now, this is more for future days, but what do you notice here? We did have a 0 at pi. What is it here? It is a minimum there. Okay, after 3 pi over 2, what's my graph doing?
Increasing.
It's increasing over here, which means on the derivative it is positive because it's above the x-axis. Oh, I forgot to mention, what was at 3 pi over 2?
A 0.
Yeah, it's a 0 here because on the original graph it was a min. Okay, are you seeing some of those connections?
Sort of. Yes.
Okay, because that is a huge thing to be able to work and say, okay, here's my original graph, here's what the derivative graph looks like. Okay, I don't think they tell us, so we're going to fill them in. We don't have a graph to look at. Derivative of sine is cosine, and I'm just going to tell you the derivative of cosine. We'll take a guess.
Sine.
Sine.
Tangent.
Sorry.
Negative sine.
About negative sine. Okay,
Wow.
derivative of sine is cosine.
You're so
Derivative
great.
of cosine is negative sine, so it's a reverse situation there.
Oh, so then is sine or tangent, would that be sine over cosine?
Cosine over sine.
No.
Negative cosine over sine.
Negative.
Secant squared x. All right.
None
None of the above.
It doesn't. Yeah, it doesn't. You guys weren't guessing it, which is why I just wrote it. Sorry.
Cotangent.
Yeah.
Okay.
Yeah. Okay. So, folks,
Done.
memorize. Okay. Memorize. That's what you're going to have to do with derivatives. There's not going to be a formula sheet on your next test that has a bunch of derivatives listed.
I just just
Okay.
pronounce rocks on.
Wait, so what's the
Who knows?
Make
Maybe
one.
you do.
know the graph of secant squared x? I don't know that.
Did you hear the government song?
No, you don't have to know the graph.
I always have to know that.
You just have to know the derivative of tangent of secant squared.
Just know my class.
Okay. This next section talks about graphing derivatives with a calculator. You enter the function as a function of x to be evaluated at the value of x instead of an actual number. And so here, it's been a hot minute since I've done this. Grab your calculator.
Don't have to tell us, guys. Except the demo. Except the demo. Throw it over here. You have a hole in your backpack.
It's supposed to be there, but it's got bigger.
Okay, so the idea here, if we want to graph the derivative of sine, okay, you don't have to know what sine is to graph the derivative of sine is the idea. So remember we learned to do derivatives on the calculator, and that is in the math menu,
8.
number 8, or it is in alpha F2 as number 3. Now, you're still filling in a variable, x, and then if I want to see the derivative of sine, we're going to do sine x. You have to put the extra parenthesis in there around the x.
Oh,
We're not looking for a certain value, so we're going to evaluate it at x, which is just going to give me the whole graph. Now, this is fine. This is going to graph the derivative of sine. What do we know about the derivative of sine? cosine. So what should this look like?
I got a straight line, but
Check your mode.
yeah.
If you're not getting a curve, check your mode. Trig functions, we always want to be in radians. Now, I like Z-trig as
There
my
we
zoom window here. So number 7 in my zoom menu is Z-trig. I like that one just because it shows a little bit better. My calculator is obviously in slow motion.
-2. So is mine.
Okay, maybe it's just because it's graphing the derivative.
How do we get a match
But-
solution?
This is sine x. If I graph cosine x in my y2, guess what? It's tracing. It's overlapping. Okay, what questions do I need to answer? I heard something. Or did you answer yourselves?
Yeah, because the cosine went faster than the derivative.
I think it was probably
Mine did.
taking longer to figure it out.
Wait, am I graphing cosine x now?
That's what I
If you
did.
do graph
Just to
cosine
show
x,
you that they're the same.
you do get negative x. Negative
Yeah.
sin x.
Now, and as we say, if we want to go up and change this out, so if we want to do the derivative of cosine x now in number 1, then in order to get to match, I would see right there, this is the derivative of cosine. Notice I'm not coming up with sine, I'm coming up with a reflection of sine.
What
So-
are you doing?
I would have to do negative sine x.
Really? Are you?
Okay. So, just some fancy information. I'll be honest, I don't graph derivatives a whole lot on my calculator, but not to say there's not times that I could possibly do it, and I just don't think to do it. So,
Mario, hold on.
okay. I don't think I have anything else to say on this page, although I lost my notebook.
Me and Mario talked to the internet.
That's pretty cool.
Mario never plays that.
Okay. So that's the derivative of sine x, or it is cosine x. Okay. You guys ready to move on?
Whoa.
Two more pages.
3 pages down, 2 pages to go.
Okay.
Let's go.
Ooh, I've got to go.
You're leaving?
No, I'm looking at the time. I don't even remember the bell ringing. Yikes. Okay. So we'll at least do A because I've got to at least do one of these, but then we may have to jump to get the other one.
That's
Okay. Couple of things here. Using limit definition for the derivative, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h, we can derive that f prime of x for each of the following trig functions. You'll verify the derivative of the sine and cosine functions by using the sum and difference formulas we learned in pre-calc. Okay, so recall, first of all, the limit as h approaches 0 of sine h over h, that's from this year, is equal to what?
Is it
cosine h.
Oh, 1.
1. It's one of your special limits.
Oh, I think I missed that day.
The limit as h approaches 0 of cosine h minus 1 over h is 0.
0.
These are back in unit 1 somewhere. Don't ask me where. Now, the it talks about sum and difference formulas you learned in pre-calc. Okay, dig deep, folks. Dig deep. Sum and difference formulas. Cosine of x plus h.
Is that cosine of x plus cosine of h?
No. Try it is cosine. Wait, which one's which?
Oh, wait, that.
Is it cosine cosine
Oh.
minus sine sine, or is it?
Oh!
Yeah.
I forgot to do this on
It
the
is
test.
that.
I remember that.
So cosine of x plus h. This was sum and difference identities. This is lesson 5 point. It's purple paper. It's 5 point
My notebook.
something or other. But cosine x plus h is cosine x times cosine h, opposite sign, so minus sine x sine h. Sine of x plus h. This is the one that you mix and match.
Is that cosine
It's
x?
sine x cosine h keeping the sign the same, and now flip, it's
Sine H.
cosine x, sine h is how I write it, but get the pieces there. Okay, now, I'm going to show A. I'm probably going to skip B today because I have to do that back page yet. The derivative of sine x is equals cosine x. That's a statement. It says show. So we're going to use that limit definition. So I'm going to start with dy dx, the derivative of sine x, is equal to. And we're going to do our definition of a derivative. So the limit as h approaches 0. And it's f of x plus h. Well, what is my function? What is f of x? Sine, yes. Okay, so f of x plus h is going to be sine of x plus h minus f of x. So minus sine of x all over h.
Oh my goodness.
Okay. Now, we have to make something happen here. And you guys know plugging in 0 right now isn't going to work. The limit as h approaches 0. Well, sine of x plus h. Pre-calc. This is your, we need a different way to write sine of x plus h, so we can use sum and difference identities.
The one on the right.
Sum of sine and cosine. So sine of x plus h, we already wrote this out. Sine x, cosine h, keeping the sign the same, plus cosine x, sine h, minus the sine x, it's already there, all over the h.
Can you can't subtract those sine x's, right?
No.
That's what I thought.
Okay.
You can factor out.
Yeah.
Right, but I'm trying to remember which way it is here. We don't want to factor out a sine x of all of them. We're going to do it of just a piece, in which two pieces.
That last
The
one.
sine x cosine h and the sine, oh wait, we can't factor a sine x out of all of them because they don't all have a sine x. But do we have two that have a sine x? Okay, we're going to factor it out of those two. So the limit as h approaches 0. I am factoring sine x out of the two that I can factor sine x out. So when I factor that sine x out, I'm going to be left with cosine h minus 1 in your parentheses, and I still have cosine x sine h all over h. Now, I know you guys probably don't see it yet, but we're going to break it into two parentheses, or two limits here. Okay, we're going to break this into two limits because we have one denominator, right? We can take this one fraction and split it into two fractions, keeping the denominator in both pieces. So I'm going to say the limit as h approaches 0 of sine x times cosine h minus 1 all over h. Plus, we're going to break it into, we're going to have our other one, the limit as h approaches 0 of cosine x sine h all over h.
Wow.
Now, do you see it?
No.
Cosine h minus 1 over h.
Oh, yeah.
Cosine h minus 1 over h.
Oh.
Oh.
Over here.
Sine h over h.
That's the magic that we designed to happen here. Okay? And I called it magic, right? What other way to describe it than that? So, The idea here is that this one, when you do the limit, is going to become 0. This piece, when we do the limit, is going to become 1. So now, are you seeing where we're going with this? This first piece is gone and is 0, plus this other piece, the one part is 1, but then it's the limit as h approaches 0 of cosine x. Well, it says h approaches 0. There's no h to plug into, so it's just going to be cosine x. And there we have our cosine x. Okay? Now,
So it's like a proof.
yeah,
Oh.
it did say show. Now,
Oh.
as you can guess, okay, we just did the derivative of sine is equal to cosine. You can guess what's going to happen on part B, right? It's going to be similar type pieces of information. You can look at that. But I will make sure you have down here the derivative of sine x, or f prime of sine x is cosine x. The derivative of cosine x is negative sine x. Work to get those memorized. Sorry to rush you on, but I know you're horribly upset we're skipping that one.
Shame.
We've got to talk about these two special cases. So derivative of sine is cosine. Derivative of cosine is negative sine. The derivative of e to the x is e to the x.
Oh, that's handy.
It is. It's the only thing I know where the derivative is itself. Okay? Only function, it even says it right here, huh? Has itself as a derivative. If f of x equals e to the x, the derivative of e to the x is e to the x. Also, the other one we're learning, if f of x equals the natural log of x. This is only for natural log. Log base anything else has other rules. The derivative is 1 over x as long as x is positive, and that's just because in order for natural log to exist, x has to be positive. Okay. Use the laws of logs to find the derivatives of the following. Okay. Here's the deal, guys. We have a derivative for natural log. We don't have a derivative for natural log of x to the third. Okay? And there's some tricks here. And so, how do I want to do this? We had a rule in our, going back to just pre-calc, forget calc for a moment. Laws of logarithms. What do we know about that power? A power in a log can be moved out front to be written as a coefficient. So this can also be written as 3 natural log of x. Now, 3 is just a coefficient, yes? It's just a number. No big deal. What is the derivative of natural log of x?
1 over x.
1 over x. So then this derivative is going to be 3 times 1 over x.
So it's just 3 over x.
So 3 over x is how you would write your final answer. Okay. Now, product rules for another day, folks. We're not doing product rule here. And I know that means nothing to you. But laws of logs first. No derivative right now. If there's multiplication inside the logs, it can be rewritten as 2 logs being added. So natural log of x squared plus natural log of e to the x. Now, go a little bit farther with this.
2 natural log of x plus x.
Move your power out front. 2 natural log of x plus, move this power out front, x natural log of e. Now, as we start to think about derivatives, 2 natural log of x. You're going to keep the 2, and the derivative of natural log of x is 1 over x. I'm going to multiply by 2, get 2 over x as final answer. Now, there's a catch on this one, guys. Natural log of e.
Log base is e.
Yes. So if natural log of e, that is base e, what is log equal to when the base is the same as the inside of the log? It's equal to the power, and my power is currently 1. And so if this becomes 1, we're just left with x. But what is the derivative of x? 1.
So 2x. 2 over x is 1.
Mm-hmm.
Is this just a special case?
This, like,
Yeah.
that's not normal that you see.
Like, I didn't follow. I followed a little bit of it, but not much.
It's just, I mean, it's just knowing that, in all honesty, we could have even just looked at this.
See, that's what I was thinking.
You could have, yeah. These e's, so then this is just equal to the power, which is x.
Yeah.
And then what is the derivative of x? The derivative of x is 1. So yes, we could have done that too. I was just in the mode of moving exponents and didn't think about it that way. Okay. What's important here? Yeesh. All of them? Oh well. Let's get some basics. I like this one. It's a basic one. Derivative of natural log of x.
1 over x.
Minus. What about 1 over x?
That's the negative 1.
Ah, you guys seeing that? Think of this as x to the negative 1, so this becomes
Negative 1 or
Plus
1
1
x
over
to the negative 1. Oh, sorry. I'm one step behind. That's just
X to the negative 1, which is 1 over x. Squared.
okay. Oh, that did not go well. Okay, so 1 over x is the same as writing x to the negative 1. Check? Then we take the derivative. Move the negative 1. Negative 1 times the negative, sorry, there, makes it plus. Subtract 1 from the power. Negative 1 minus 1 is negative 2. So this derivative is the 1 over x plus
1 over x squared.
1 over x squared is where I was trying to get us. It just did not go well. Okay. We're not gonna have time to finish this, but division inside a derivative or inside of log is what?
2 of them subtract.
Yeah. So this would be the log of 2e to the x minus log of 3x that you'd want to take the derivative of. Yes? Okay. I'm stopping there in that annoying place because the bell's ringing. Have we done and seen a little bit of everything?
Yes.
I think so.
Yes.
I was.
Now, work homework. You've got some basic derivatives. You've also got some information where they're taking you a little farther there. Okay? So, homework is available. Key is posted. Work through everything.
Remember when I texted you and said I told you I texted my mom? It's like, your mom just keeps sending me out. I wasn't home. She's just